Economist magazine that the data is the new oil. That's really our reality. However, if you look at the data as the new oil, it's same as oil. It's not so easy to extract, not so easy to deliver. And naturally, data is the foundation of all our modern data initiatives in the areas of predictive and prescriptive analytics, data science, and artificial intelligence. And now I would love to take kind of a couple of steps back and speak about the evolution of data management, how our science was evolved in the last like 20, 25 years. And if you look at that, you will see that IT organization that was dealing with the data that always had a dream. And that dream, unfortunately or fortunately, it never came true. And most probably will never comes true. If you speak about the 90s, we were saying, okay, we're going to get all our data into data warehouse for analytics, for reporting. In some 20 years ago, we started speaking about the cloud, and the idea was, okay, we are going to move all our data to the cloud. And then we were going to solve all the challenges that we have in our data strategy. 10 years ago, we started speaking about the data lakes, about Hadoop technologies, and everyone was saying we move all the data into a single data lake and everybody will be happy. Unfortunately, this concept never worked. If you look at any organization, any big organization now in the modern world, you will see that some of the data is still in the data warehouse for reporting and some other purposes. You have a lot of data moving to data lake, and most probably you have several data lakes already. As Chuang mentioned, that might be some business data scientists or business analysts who are doing their own exercises, own like researches on the data. Some of the data moving to the cloud already. And so currently what do we have is naturally our reality in 2020 and beyond is that IT organization keeps trying to get all the data into the single repository, but those data, they really siloed across the systems, across the repositories, across the data warehouses, data lakes, clouds. Now we see that some data moving more and more to the edge. At the same time, our business organization is increasingly demanding from IT that we would provide all the data now, because the business requires us to do the real-time data analytics, faster data integration, better data discovery, all those aspects that are really needed. Even we are not speaking about the competitive advantage anymore. We are speaking about the whole survival of the organization in the modern world. If you are not doing the proper data analytics, you will not survive in the next 10, 15 years. This is the dilemma that we have to deal with right now. The data volumes are growing. We can see that the new data types are coming and coming. New technologies are coming, like self-driven vehicles, like a 5G, mobile technologies, like IoT devices that are here and there. And IT keeps trying to get all the data physically collected and stored in the single repository. As the solution for this problem, all this kind of a general agreement among data professionals all over the world. And if you read some analytics from the companies like Gartner and Forrester, you can see that there is a general agreement that the way going forward is to go to the data virtualization, to move from the idea of storing all the data in a single physical location to the absolutely different concept of having a virtual data. And this is basically what Gartner is saying, that in a couple of years, almost 60% of the organization, they will have to move and will implement the data virtualization as the key delivery style of the data integration architecture. Let me also give you some high-level idea what does data virtualization mean. If we speak about the data warehouses that we were building like 25, 30 years ago, we're moving the data into the very solid, very predefined structure, very strict data model. And the speed of the data was really slow, right? We were moving the data most probably during the night in the batch mode, just bulking them into the data warehouse. And well, I love this analogy that if you think of the states of the matter, right? At that time, our data was kind of frozen. Our data was in the form of ice. And we were using this similar, like a very cold terminology. We were building the cubes, we were building snowflakes, right? So the data was really in a solid state. What happened next when we started working with the data lakes, and you can see from the terminology already, our data started to melt. Our data started to turn from ice into the water. And we started to use the same terminology like data lakes, maybe data swamps. And what's the difference, major difference from the data management perspective? If you look at the data lake and the data warehouse, and the data in the data lake, they do not have a solid predefined model anymore. We are using the term schema on read. So our data is taking the shape of the container, same as liquid. Moving to the idea of data virtualization, to the concept of the data virtualization, we can say that our data currently started to vaporize. We are working with the data in its gas state. The data does not have a shape anymore, and they don't even have a predefined volume anymore. The volume and the shape appears when you read the data. When you run the query to your data, when you request the data, you're going to get a certain data set in a certain form with a certain data volume. That's the very high level introduction of the concept of the data virtualization. And in the next like 10-15 minutes, I want to show you how data virtualization concept work with the modern architectural approaches that is being implemented all over the world. And that's something that we really need to start thinking of if we want to be successful now and successful in the future. And we want to speak about three trends in the modern data architecture that we can see right now. And those three trends, it's all about the virtual data fabric, data mesh, and multi-cloud architecture. Those are the modern architectural styles that companies are implementing in order to address the data challenges that we currently have, to address that challenge of growing business requirements, growing volumes of the data, new technologies coming into the picture, and the ability of the IT organization to address all those challenges and to provide the proper data for the artificial intelligence, for predictive, prescriptive analytics, for data science, for data monetization, data democratization, all those modern initiatives. And basically the foundation for all those three modern data architecture is the data virtualization as a technology. So if you want to build the proper data fabric platform, you want to use the technology of data virtualization. If you're speaking about the multi-cloud architecture, data virtualization is something that you need to manage your data properly. Let's go one by one, those three architectural styles, and let's see how it works in reality. And at the end of the presentation, I will show you a very good example what actually Denodo built as a kind of a homework exercise, right, to help the data scientists all over the world to analyze the data related to COVID-19 and using basically the data mesh approach. So let's speak about the virtual data fabric first. Virtual data fabric is the architecture that is designed to stitch together historical and the current data that is sitting in silos across the organization and produce a uniform and unified business view of all the data. The main idea is here that we are not moving the data physically anymore. That's the main idea of all those three architectural styles. You simply cannot afford moving all the data into the single location. The data volumes are growing so fast, and the technologies are evolving so quickly that it's becoming simply physically impossible to store all the data in a single location. We want to provide a layer that gives us the abstraction, gives us the unification of the data without physically transferring the data from point A to point B. Let's take a look at the architecture of virtual data fabric. That is one of the most popular modern data architectural concept nowadays. You have all your data sitting in the different repositories inside of the organization. It can be traditional relational data stores. It can be your existing data warehouse on the traditional relational technology. It can be some NoSQL repository that stores the data. Maybe it's MongoDB or some other technology you are using for that. You have most probably a data lake already, or maybe several data lakes in several departments. You have some data sitting in the documents and the Excel spreadsheets that data scientists really love to work with, but those data, they might be not even integrated into either of those repositories, right? You might have moved portion of your data into the cloud already, your data in the cloud, and you are dealing with the data coming in real time more and more. You are dealing with the data coming from IoT devices. You are dealing with the data coming from sensors. Maybe you're analyzing the web logs, maybe you're analyzing the click streams. All those data sources there are required to provide a valuable input for modern data initiatives in the area of data science, artificial intelligence, predictive analytics, agile business intelligence, alerting. And how can we do that without physically moving all those data into the single place? We can connect those data to the virtual data fabric platform that would be getting the data, extracting the data on the fly in real time, combining them as needed, and providing them for all those projects in a centralized, unified, and manageable manner, providing at the same time the abstraction layer, providing the unified view of all the data that you have, providing end-to-end very granular security for the data, and allowing all those projects, all those groups and the people in your organization to access the data in a centralized and the universal way, so that your data scientist or your business analyst, they do not have to go and look for certain data sets, running from one room to another, trying to understand if those data set is in the data warehouse or in the data lake or in some flat file somewhere, and how to get access to those data as well. The centralized, unified, abstracted layer that is providing all the data in a unified manner to everybody in the organization. Also managing the security at the very granular level, as I said. And of course, to manage all this platform, you really need to have the mature data catalog capabilities, and you need to have a tool that allows you to understand how your data are moving from point A to point B, what kind of data you have in a certain data set. It gives you the ability to preview the data sets and download them if it's possible. This is the virtual data fabric architecture that is basically people are building to address the data challenges inside the organization without physically moving data from point A to point B, as I said. As a logical extension of this architecture, we also see the rise of the architectural approach that we call data mesh. How does that differ from virtual data fabric? The difference is in the kind of a point of view at your data. If it's virtual data fabric, we were talking about connecting to all data sources in real time and providing the combined unified universal access layer to all the data from more or less like an IT perspective. So here we are coming from the ownership perspective. If some unit in your organization owns certain part of the data, let them own that. If you're working with some third-party organizations that they own another data set, let them be there. So data mesh concept is more like about the data ownership, but the idea is basically the same. We are not moving the data and we are not moving the ownership, right? whenever you move the data physically from the third-party organization to your inside of your like a firewall, you own the data. The idea of data mesh is that the ownership stays where they are and the data stays where they are. However, the concept of data mesh is that it allows the data sources to remain distributed and controlled by different organizations and be owned by different organizations. Organizations means the units inside of your company, or it's maybe organization outside of your company. Let's think of like some government initiatives when we need to collect the data from all the ministries in the country. We don't want to move the data physically. We leave them where they are with those ministries, and they own the data still, but we can provide a unified, combined view of all those data and run our data science, artificial intelligence projects, train our algorithms on those data without physically moving them into the single kind of a repository. The architecture of data mesh platform is pretty much similar to what we've seen with the virtual data fabric. However, the data sources can be really the same, but owned by different people. However, what we do with those data sources, same way, we are connecting them to the virtual data mesh platform, and we are providing those unified, combined, abstracted data for any kind of consumption, for data scientists, for data analysts, for our data stewards to govern the data. Same concept of data virtualization works perfectly for data mesh architecture too. Let's move to the third major trend in the current data management, and let's talk about the multi-cloud architecture. Really, the cloud journey, and it's again, there is a general agreement among the data professionals around the globe that we will face very soon a multi-cloud world, because the competition on the cloud market is really strong. The providers competing for the customers, and some of them providing better capabilities in terms of storage, for example. Some other cloud service provider can provide much better capabilities in terms of data analytics. So most probably you will end up having some of your data in Amazon, as a part of data in Azure, and some other data sitting in Google Cloud. Maybe Alibaba Cloud comes here to the picture. Some other providers, the newcomers, will enter this world. So multi-cloud architecture is something that is really becoming the reality. This is a kind of a high-level picture of the architecture, something that the company is going to face very soon. We still keep some data on-prem. However, other portion of the data will be sitting in the different clouds. And again, the same question comes: how do we manage all this data? How do we provide a unified view of all the data assets for any kind of a project that requires the data? And the answer is a data virtualization platform that can connect to all those repositories in real time, get the data from multi-cloud architecture, multi-cloud landscape, and provide those data again in the abstracted, unified, and secure manner, provide those data for the consumption of all the projects that requires the data. And definitely enterprise kind of data catalog capabilities that without that you cannot imagine really the modern data management platform. And this is something that you need to manage and govern your data properly. This is the architecture if you want to move to the multi-cloud world, and most probably you will find yourself there sooner or later. I just want to give now the closing remarks because I have some 6 minutes left. And as the example of, as I promised, I want to show you something that we built when we got locked down in the company. We decided to build the portal with the open data, whatever data we could find about the coronavirus globally, all the data sets, we found those data sets and we virtualized them utilizing the data mesh technology, data mesh architectural approach. And what you can see now on the screen is this screenshot from our data catalog. And you can see that at the left side that there are a lot of data, a lot of like folders with the data, and not only the data about the coronavirus itself. There are lot of demographic data about the status of the healthcare in a certain country, the status of the education system in the certain countries, was there lockdown, or when it was lifted, if it was not lifted. All those data here, all these data sets can be previewed and analyzed. And if certain data set is needed for your data scientific experiments, you can download the data set. Again, I'm repeating, we didn't move a single byte of the data from here. We are just virtualize the data from all over the world in a single place where every data scientist can come, search for the needed data set, download that, and train the models trying to find the solution for this or that problem. The key takeaways of this presentation is the data virtualization is the technology that it provides the foundation for any kind of modern data architecture, whether it's a virtual data fabric or data mesh or multi-cloud architecture. And the flexibility that we provide, it gives us the way to speed up time that required to move new projects to production up to 10 times. And data virtualization, it hides the complexity of the original data sources, because business really doesn't care if the data is in Oracle or in Hadoop Cloudera, or it's in MongoDB or in a flat file. They just need the data. That's what we do. We are unifying, abstracting, decoupling the data sources from the consumers. We are making them all similar. And it allows us to really provide the granular level of security right here inside of our platform. And this is Denodo recognized by the Gartner and Forrester for being the leader in the area of data virtualization and data fabric. And I'm inviting you to like a closer conversation if you have something to discuss. We are here, we are at the event all 2 days. And thank you so much. This is the time for Q&A.
Thanks